discuss the convergence of the sequence a sub n, which is going to be n factorial over n to the n, where n factorial is 1 times 2 times 3, all the way up to n. Yep.
What is the explanation on?
It's a factorial. It means when you're taking n factorial, so for example, if you're doing, let's say 5 factorial, let me do this in red or blue. 5 factorial, it's 5 times 4 times 3 times 2 times 1. It's whatever that number is. I think it's 120. Yeah. Okay, so this problem says discuss the convergence, so maybe what we're gonna do is just write out some terms of this sequence to see what's happening. So let's take A1. What am I gonna get for A1? 1 over 1, which is 1, yep. A2. So, 1 times 2 over 2 squared, so 2 times 2. So 2 over 4, if you want to simplify it. Or 1/2. Okay. Okay, let's write out A3. So 3 factorial, 3 times 2 times 1. Oh wait, I want to start with 1 in front. That's what I did on the last one. 1 times 2 times 3 over 3 cubed. So 6 over 27. So I think we want to think not simplified at first. So if I write out the general term a sub n here, I'm going to have in the numerator 1 times 2 times 3 all the way up to n. And in the bottom, I have n copies of n. N times n times n. I have the same number of things being multiplied in the numerator as I have in the denominator, right? Okay, so what I'm going to do is I'm going to think about this. I'm going to separate off the first term in the numerator, which was a 1, the first product, 1 over n, and then I'm going to be left with everything I had left. Okay. And let's think about this expression here in this parentheses. What can I say about this number here? So if n is 2, right, this is 2 over 2, which is 1. If n is 3, it's 2 times 3 over 3 times 3. The numerator is smaller, right? And after that, if you plug in n equals 3 or 4 or 5, the numerator's smaller. So this number here in this parentheses, it's at most 1. It was 1 when I plugged in n equals 2, but after that it was smaller than 1. So what this means is that a sub n, I knew that it was positive, so it's greater than or equal to 0. Actually, strictly greater than 0. But now I know it's less than or equal to 1 over n times 1, which is just 1 over n. Yep.
So in the parentheses, is it at most 1 because
Like if you plug in 3, it's 2 times 3 over 3 times 3. And then-
Yeah, because you have the same number of things being multiplied in the numerator and denominator. So if you look, when we wrote down these examples, I have the same number of things being multiplied in the numerator and denominator, but the terms in the denominator versus numerator, right? The numerator terms are smaller, right? So if you look at this, let's look at A3 here. So what's in parentheses is this part right here. So if you look, that 2 versus that 3, the numerator is now guaranteed to be smaller than the denominator. And when you divide a smaller number by a bigger number, it's less than 1. And if you need to write out A4 is going to be 1 times 2 times 3 times 4 over 4 times 4 times 4 times 4. And what we're talking about in the parentheses is this term right here. I have 3 numbers in the numerator and 3 numbers in the denominator, but the ones in the numerator are smaller, right? So I'm getting a smaller number in the numerator each and every time. Except for the case when we did A2, it was the same number. That's why it is 1 for n equals 2, but after that, it's smaller than 1.
Thank you.
Yeah, no problem. Other questions? So look what we just did, this inequality. My sequence is bounded between 2 things, right? Which makes me think of what I told you last time was the squeeze theorem. My sequence is squeezed between 2 objects, squeezed between 0 and 1 over n. So it's telling us maybe we should use the squeeze theorem here. So you got to take the limits of both of the squeeze, the 2 side pieces. The limit of 0 is 0. The limit of 1 over n, what's that? 0 as well, right? So if they're the same, and I look, I got the same limit, then this one in the middle has to have the same limit as well. Okay, just using the squeeze theorem. But the work was to try to figure out what to squeeze it between. Okay. The one thing you might want to think about is, let's go back to the top. These are fractions, my terms here in my sequence. And what's happening to the numerator? 1 times 2 times 3, all the way up to n. That's getting really large, right? For large values of n. So the numerator is infinity. The denominator is also infinity. So what does infinity over infinity make you think of?
L'Hopital's rule.
L'Hopital's rule. But there's a little bit of problem here because of this factorial. N factorial is only defined for integers, not, any other numbers other than integers. So decimals, anything, fractions. The factorial is only defined for positive whole numbers. So in order to use L'Hopital's rule, we have to change it into a function, right? But we can't because of the factorial. Okay? So it's okay to think about other possibilities, but sometimes they do work and sometimes they don't work. Like I said, your inclination is maybe you want to use L'Hopital's rule, but you can't use it here, which is why we had to resort to the squeeze theorem.